Hello, this is DVKT Math, and in this video we're gonna solve this differential equation. dy over dx is equal to 3x plus 4y plus 2 over 4x plus y plus 7. And to solve this differential equation, we're gonna use some sort of a trick, I guess. And before getting into the solution, I'm gonna explain the trick that we're gonna use first. So for any, I'm gonna change to blue because I like it better. For any differential equation of the form dy over dx is equal to a1x plus b1y plus c1. I'm not really used to like writing on my phone screen with my fingers, so it looks kind of bad, but well, over a2x plus b2y plus c2. And there's for any differential equation of this form, well, a1, b1, c1, and a2, b2, c2 are all constants. They are just some numbers. And then for any differential equation of this form, there's a trick to solve it. And so first, for the cases when c1 and c2, well, for the cases when c1 and c2 are equal to 0, then we simply need to substitute y is equal to xv or u. You can use whatever like variable you want. You can substitute y equals xu to turn it into a separable equation, and I'll leave it to you to work it out to see how it will turn out to become a separable differential equation. It should be pretty straightforward. So the trick here is when c1 and c2 are equal to 0, you substitute y is equal to xu, and then y prime, the dy over dx, is equal to u plus xu prime. So, and then the other case is when, so that was the case when c1 and c2 are 0. Now when c1 and c2 are not 0, then, so this is when c1 and c2 are not 0. Then we have two cases for this, like two subcases. So when a1 over a2 is equal to b1 over b2, so when a1 over a2 equals b1 over b2, the coefficients for x and y, the ratio of those coefficients, when they are equal, then we substitute v. I'm going to change black to blue. We're going to substitute v is equal to a1x plus b1y plus c1. Oh, no, not that. Wait. What was the trick for this? I kind of forgot. Well. Oh, right. So for this case, when a1 over a2 is equal to b1 over b2, we substitute v is equal to a1x plus b1y, and then it will turn into a separable differential equation, right? Yeah, right. So yeah, that's right. It will turn into a separable differential equation after you substitute v is equal to a1x plus b1y in this case. And then the second case for when c1 and c2 are non-zero is when a1 over a2 is not equal to b1 over b2. Then in this case, we will find the intersection of the lines, the intersection of the line a1x plus b1y plus c1 is equal to 0, and the line a2x plus b2y plus c2 is equal to 0. So we will find the intersection of these two lines. So basically these two lines are the numerator equal to 0 and the denominator equal to 0. Let's say the intersection of those two lines is hk. It's the point hk. Then we can substitute x equals u plus h and y equals v plus k, or you can use any other variable you want to other than u and v. But basically the idea here is you find the intersection of the two lines, the numerator equals 0 and the denominator equals 0, and let's say the intersection is hk, then you substitute x equals u plus h, or you can use any other variable than u, and y equals v plus k, or any other variable other than v that you prefer. And then after substituting this, you will see that the c1 and c2 will become 0, and after that, since z1 means c1 and c2 are 0, then we can just substitute v equals u times something. Like when c1 and c2 are equal to 0, we just substitute y equals xv, like x times something. So same thing here. After substituting this x equals u plus h and y equals v plus k, you will see that the c1 and c2 will just vanish and it will become 0. So after that you can just substitute v is equal to u times something, like let's say t or s or g, h, whatever you want. Maybe not h, because it would be a little confusing with this hk over here. But anyway, so that's the trick ish. And well, so let's get back to the main problem. So our main problem here is dy over dx is equal to 3x plus 4y plus 2 over 4x plus y plus 7. So here you can see that 3 over 4 and 4 over 1, they are not equal to each other. So that's like the case 3, like the second case of when c1 and c2 are not 0. So the first step that we need to do is, well, so we'll find the intersection of these two lines. So the numerator equals 0 and the denominator equals 0. We'll find the intersection of those two lines, and it should be easy to find. It's just solving a system of linear equations. And then after, so you can do it on your own, and then after solving for the intersection, I don't know what's wrong with this board. Where can I? Oh, I can draw now. Anyway, so after you find the intersection of those two lines, you can find that the intersection here is, and what's happening again? Great. So the intersection is, and why can't I draw again? Sometimes I just hate this board. Anyway, so the intersection is, again, the intersection is -2, 1. Yeah, I don't know why I'm struggling with using this board so much. Anyway, so the intersection of these two lines is -2, 1. So you substitute, so we can substitute x equals u plus -2, so u minus 2, and then y equals v plus 1 here. And then, so after substituting x equals u minus 2 and y equals v plus 1, well, dx is still du and dy is still equal to dv, and so you get dv over du here. Dv over du, you just plug it in, x equals u minus 2 and y equals v plus 1, simplify, and you get this equation. dv over du is equal to 3u plus 4v over 4u plus v. So you can see that the c's, the c1 and c2, they vanished. So we only have the 3u plus 4v over 4u plus v. And at this point, you can substitute v equals u times g, or you can use any other variable that you want other than g. But basically you can substitute v equals u times g, and then dv over du is, using product rule for derivatives, is equal to g plus u times dg over du. Alright, and then just substitute them in this equation. Then we get this equation. g plus u times dg over du is equal to 3u plus 4ug over 4u plus ug, because v is equal to ug. And you can see that the u will cancel out. And then, so the u will cancel out. And then, well, subtracting both sides, subtracting g from both sides. And then, well, simplifying it, rearranging it, dividing both sides by u, and dividing both sides by this 3 minus g squared over 4 plus g. So basically at this point you're just doing some algebraic simplification for the equation. And then here you can see that we get a separable differential equation. And to solve this separable differential equation, we just need to integrate both sides. So I'm gonna go to the next slide. So integrating both sides, this is what we get. You can check it on your own. It should be a straightforward, simple, well, not really simple because the numbers are not really nice, but it should be an easy integration. And after integrating both sides, you will get this equation right here. So 4 times square root of 3 minus 3 over 6 times the natural log of square root of 3 plus g minus 4 square root of 3 plus 3 over 6 times natural log of square root of 3 minus g is equal to the natural log of u plus c, where c is some arbitrary constant for the integration. So that's the general solution for the equation. And now we need to plug back in the g and the u. So we substituted v is equal to ug. So g is equal to v over u. And so that is equal to y minus 1, because y is equal to v plus 1. This is what we substituted. So v is equal to y minus 1. And then x, we substituted x is equal to u minus 2. So u is x plus 2. So here g is equal to v over u, which is equal to y minus 1 over x plus 2. And then the u is equal to x plus 2. So we plug back these values, not values, but these expressions for g and u into this equation right here. And then we get the general solution for our original ODE, for our original differential equation, which is this thing right here, this long thing right here. I'm not gonna read them out loud because it's just too long. And so yeah, here's the general solution for our original differential equation. I don't remember it, so I'm gonna go back to the last slide. So that's the general solution for our differential equation. dy over dx is equal to 3x plus 4y plus 2 over 4x plus y plus 7. And so that is our, I'm gonna go back to the second slide. And so that is our general solution. This whole thing equals c, where c is some arbitrary constant. Alright, thank you for watching.